Students will be able to find solutions to exponential problems. Solve given x equals 0 and y equals -3. Let's split the differentials. Actually, we're going to split the variables in the differentials. So we divide by y plus 2 squared. And we have dy is equal to 2x dx. Now we're going to integrate both sides. Now this left side is y plus 2 to the -2. So when we add 1, we get y plus 2 to the -1, but then times -1. This left side is -1 over y plus 2. And then the right side is x squared plus c. Let's plug in the values. We know that x equals 0 when y equals -3. So we have -1 over -3 plus 2. That's equal to 0 squared plus c. That's -1 over -1. That's 1 is equal to c. Now we're going to go up to this spot right here. We have -1 over y plus 2 is equal to x squared plus 1. Now we can multiply by y plus 2 and divide by x squared plus 1. So these two things kind of switch places. So y plus 2 is equal to -1 over x squared plus 1, and then y is equal to -1 over x squared plus 1, and then minus 2. On number 8, we need to be able to free up the y here. So let's write this. Let's say dy over dx is equal to e to the x times e to the negative y. And then dy dx is equal to, we can write this as e to the x over e to the y. Let's multiply by e to the y, and we'll multiply the dx over to the right side. Well, now we need to integrate both sides, and we have e to the y is equal to e to the x plus c. Now let's plug in 2 for y and 0 for x. So e squared is equal to e to the 0 plus c. Now that's 1. E to the 0 is 1. So c is equal to e squared minus 1. Now we can go up to this spot right here. E to the y is equal to e to the x plus e squared minus 1. And then we just finish by taking the natural log of both sides. So natural log of this side, natural log of this side. We have y is equal to natural log of e to the x plus e squared minus 1. In exercise 11 through 14, find the solution of the differential equation dy dt is equal to k times y. K a constant that satisfies the given conditions. So let's divide by y. So we have 1 over y, dy, and then multiply by dt. So we have k dt. Now we're going to integrate both sides. Integrate. And this is the natural log of the absolute value of y is equal to, k times t, and then plus c. Now, y is equal to e to the kt plus c. And then we can split that into e to the kt times e to the c. But c is just c, so y is equal to c e to the kt. Now, look what happens when we plug 60 into this. So 60 is equal to c e to the k times 0, but e to the 0 is 1. So c is equal to 60. That's why, like in science, you'll see n, the amount n, is n naught e to the kt. In finance, you see that the amount in the bank account is equal to the principal. That's the initial value that you plug into the bank account, e to the RT instead of KT, and maybe you've heard of the PERT formula. But for now, we're not using these variables. We're not using these for now anyway. We are using k's and t's and all this. So now for our specific problem here, we have y is equal to, the c ended up being 60, and then we have e to the k times t. Now, that's why they give us the other point, to find the k. Now, 30 is equal to 60 e to the k times 10. And so 30 divided by 60 is a half. K times 10. We're going to take the natural log of both sides. And that's equal to natural log of e to the k times 10. This is really the natural log of 2 to the negative 1. So this is just, well, not even e to the k. This is just 10 times k. So k ends up being, and I can bring this negative 1 down. So negative natural log of 2 over 10. So the formula that we're looking for is y is equal to 60e to the negative natural log of 2 over 10 t. And I suppose we could find a decimal value for this, but this is a perfectly acceptable answer. Find the equation of the tangent line to the solution of the differential equation with the initial condition that f of 2 is equal to the square root of 2. Well, we have the point 2, square root of 2, and we need the slope, but that's the derivative. So this is equal to the x is 2, and the y is the square root of 2. So we have negative 1 over square root of 2. Negative 1 over square root of 2. So the equation of the tangent line is y minus square root of 2 is equal to negative 1 over square root of 2 times x minus 2. Now let's use our calculator to approximate this. So what I need is y minus square root of 2 is equal to negative 1 over square root of 2 times, if we plug 2.1 in here, we get 0.1. That's a 2. And we have negative 1 divided by square root of 2 times 0.1 and plus square root of 2. And we get 1.343. So y equals 1.343. Your turn. Solve with the initial condition that x is 0 when y equals 2. How about 2y dy is equal to negative x dx? And let's integrate both sides. We get y squared is equal to negative 1/2 x squared plus c. Y is 2, so we get 4 is equal to negative 1/2 times 0 squared plus c. So c is equal to 4. Y squared now is equal to negative 1/2 x squared plus 4. And then we're going to have to square root both sides. Since y is positive, we want the positive square root. So y is equal to the positive square root of, how about 4 minus x squared over 2?